we dive into going over our homework, I want to go ahead and bring up the assignment sheet for you so you can see it. You will have an assignment sheet for you next class. But this is the current tentative pacing, so obviously you had your test last class. So today we're going to talk about special angles, which is what you did in your vocab, the corresponding, the same side interior, same side, or alternate exterior, and alternate interior. And you'll have textbook for homework tonight. And then it's the typical pacing here. Lesson, quiz, lesson, quiz, review test. Now, the unique thing here is that we run into PSAT day, which this year is on a red day. On PSAT day, you guys do not come to class. So even though it's a red day, you don't go to any of your red day classes. You get to do some type of freshman, I'm not sure what they're having you do, but it's something other than the PSAT, because PSAT is sophomores and juniors. So even though it's a red day, you will not have class, which means then the next time you have class, right now red day is leading, black day will lead. That doesn't really make any difference for you guys. It only makes a difference for me. The thing is that when you look at the dates then, just know that the second date would be you guys. But it doesn't really impact our learning. This impacts for me who I'm teaching first. So that puts our test for Unit 3 right at, let's turn up the calendar here, October 23rd, 24th. That will be the last grade on first quarter. So just keep that in mind. You'll have your, obviously your 2 quizzes here and then the Unit 3 test. So that's way in advance. That's like 3 to 4 weeks down the road. Right now, we are here. So I'll post this again at the end of class so you know what your homework is. But we are in Chapter 3 in the textbook for our Unit 3. All right, so let's go ahead and take a look at our homework, and we're going to talk about our vocabulary there, because what you learned with your vocabulary is what we're going to be building upon today. All right, so our vocabulary here, we have perpendicular lines, parallel lines. Those should be something you're already familiar with. A couple of things I want you to take note of is that there is notation for perpendicular and notation for parallel, so you might want to add that onto your vocab. So basically just a little perpendicular or a little parallel. Also, for perpendicular, to indicate on the diagram that 2 lines are perpendicular, we'll draw that right angle notation there. And we already talked about for parallel, when 2 lines are parallel, they draw the little arrows on it. Try reorienting this again. Now, you, as always with everything in geometry, you want to make sure you're not assuming information about the picture. If it looks like it's parallel, but they don't tell you that it is, don't assume that it's parallel. For the majority of this unit, we will be dealing with parallel lines. But let's see if it's up here. Alright, while we're waiting for that to jump. So our new stuff then is our transversal and then our special angles. Alright, so transversal, this is when we have 2 lines that get intersected by a third line. And that line that does the intersection we call transversal. Your lines do not have to be parallel for this, just any 2 lines when they're intersected by a third line. That's called our transversal. So down here in this picture, N would be our transversal. Again, the line intersecting 2 other lines. 2 or more lines. Alright, now when we have that transversal, that creates what we call our special angles. And we have alternate interior, alternate exterior, corresponding, which we said the textbook calls same side interior. Or sorry, no, I did the wrong one. The consecutive same side. Oops. Corresponding is different. So alternate interior, alternate exterior, same side interior. And this year, the SL has added on same side exterior angles, and we'll talk about that in just a moment. So same side exterior is another one. So if you would write that across your paper. Same side exterior. Alright, so alternate interior angles. You should have the vocabulary for this, but the key thing is it inside or outside, and what side of the transversal is it on? So I'm actually going to go ahead and just bring up my Word document here. And again, we don't have to have our lines be parallel. So here's line A, and B, and line C. So this is our transversal, because it is the one doing the cutting, transversal. Now when we talk about interior versus exterior, transversal is cutting through two other lines. The interior would be in between those two lines. So this here is my interior, in between those two lines. This is interior. Exterior would be outside of those two lines. So I have exterior up here and exterior down here. This is an exterior, this is an exterior. Knowing those locations will help you in remembering where alternate interior is, alternate exterior. Alright, so I'm going to start off with actually corresponding. So corresponding angles, it's basically in the same location on each of the two lines. So you want it same side of the transversal, and then same side of your two lines. So if you're, let's say, for example, angle 1, just go 2, 3, 4, 5, 6, 7, 8. So for example, a set of corresponding here would be angles 1 and 7. So angle 1 and angle 7 would be corresponding. Notice they're both to the left of the transversal, so same side of the transversal, and they're both above the lines. So same location in terms of transversal and lines, but one's on each line there. Now we have multiple sets of corresponding. We have 1 and 7, 2 and 4, 2 and angle 4. And then again, I can go the other way, so those were both above. So I can go now on the right side below, 3 and 5. And 8 and 6. So these would all be sets of corresponding angles each. So I have 4 pairs of corresponding angles here. So again, it's similar in location on both the transversal as well as the line that it's in respect to. Now our next one that I want to talk about is alternate interior. So alternate interior has to be in the interior, and it has to be on the opposite sides, or alternate sides. So alternate interior, 3 and 7. Again, it's in between my two lines, so it's in the interior, and it's on alternate sides or opposite sides of my transversal. So 3 and 7. My other set would be 4 and 8. Now let's take a look at that as opposed to alternate exterior. All that changes is that we are outside rather than inside. So alternate exterior. Again, we need to be on the exterior and alternate sides. So 2 and 6. And then for this diagram, what would be my other set of alternate exterior? 1 and 5. Nothing too crazy. Alright, and then our last one that we have on our vocab is same side interior, or consecutive. I don't really care which one you use, same side or consecutive. Same side interior or consecutive interior. And again, it has to be interior, and it's on the same side. So 8 and 7. And then we have 3 and 4. Okay. Now the new one that the SL has added this year is same side exterior. Okay, so it's on the exterior, it's on the same side. What do you guys think would be a pair of same side interiors or exteriors? 1 and 6, good. And 2 and 5. Okay. So these are different types of special angles. We call these special angles. On a quiz or test, I'll refer to them as special angles. Those are the ones that I'm talking about. So corresponding, alternate interior, alternate exterior, same side interior, and same side exterior. So that's basically what the top chunk of our paper is talking about. So these are our special angles. If you want to write that on your vocab, so you know that's what I'm referring to. I'm not referring to linear pairs or vertical angles, right? Our special angles are these new 5 sets of angles. Okay. Now, again, just a reminder, we do not have to have parallel lines. It's any time that we have 2 lines cut by a transversal. So like I drew here, non-parallel lines, 2 lines cut by transversal, then we automatically have these sets of special angles. Now, when the lines are parallel, that's when we have some specific relationships that we'll be talking about today. All right, do we have any questions on your vocab on the top half there? Okay, so go ahead and check your answers for labeling these angles here. Let me zoom in a bit for you guys. And again, notice here our transversal is line M. Alright, do you have any questions with these? Alright, so then because this well has added on same side exterior, let me go ahead and throw that in. So what would be our same side exterior angles? Give me one pair of our same side exterior. 2 and 7. 7, good. And what's our other one? Go ahead.
1 and 8.
1 and 8, good. So what's interesting is that we always in years past talked about these same side exterior angles. We didn't necessarily give a name to it, but we talked about the relationship with them and talked about what they were. But this year they're actually putting them on the SOL, so we will actually have them in class stated for real. Okay. So let's go and take a look at our bottom chunk. Now for our bottom chunk, your answers are going to vary. Because it said use the same transversal to answer each question below. I specifically chose transversal A. So if you had transversal A, your answers will match up. But if you chose transversal B, X, or Y, your answers will be different. So we're going to actually pause here. If you had transversal A, you had transversal A up here. If you chose transversal B, go back there. Transversal X, go in that corner. Transversal Y, go here. And if you did all of them, sure, all the power to you. So go to whichever one. So what was that? A, B, X, Y. 60. I was like, you did it all. For the transversal. Do we have questions about the bottom part here? I don't care which transversal you use. You can ask questions, but you don't ask questions when it's transversal. So the very last question, it's pretty obvious now. Does your answer depend on the line you choose? Yes. So here we had multiple options for transversals because again, a transversal is defined as a line that intersects 2 or more lines at distinct points. And each of these intersected 2 other lines. So that's why we ended up having multiple options for transversals. Now on a quiz or test, we're going to specify which one to use as a transversal. So we don't have to worry about like, okay. Questions with this?
Like you did in the beginning of the year, would the transversal be the ceiling and the wall and then that middle line?
So transversals, we're talking specifically about lines instead of planes. Okay, we're talking about lines now, so we're now like 2D. Okay. So like let's say for example, see how there's kind of these beams here? And then we have this one at the top. This would be a transversal because it's intersecting these 2 things. And really it's intersecting all those things. Is that what? Now conveniently these ones are ideally parallel. But they don't necessarily have to.
Can transversal lines apply to planes though?
So we're transversals are only talking about lines instead of planes.
Okay. So
Just
just
lines.
for intersecting planes, it'd be the intersecting plane line.
And something now, guys, with moving on from here through geometry, through the rest of geometry, we're going to be mainly working with our 2D flat surfaces. And then, like, we don't do so much with planes now, more so with our lines and shapes. Shapes, yes. And then at the end we get 3D shapes for buildings. So, great. All right, other questions with this before we take a look at our textbook? Right. So let's go and take a look at our textbook answers. Okay, so now that we've taken a look at our vocabulary and our homework, our unit 3 is parallel and perpendicular lines. Today we're focusing on parallel lines. And we have 1, 2, 3, 4 theorems and postulates that we're going to be looking at today. And then we have converses of those and then a couple extras. So we're not looking, and then one after that. So we're not looking at all of these today. This is where, by the end of the unit, all of your theorems and postulates will be on this page here. So we're going to take a look at our first chunk today and then do some problems with that. Now you'll notice that our theorems and postulate for today all deal with the vocab that we were just talking about. So we've got corresponding angles postulate, alternate interior angles theorem, same side interior angles theorem, and alternate exterior angles theorem. Alright, so this is when we have angles formed by parallel lines. Okay, so for each of these, it's talking about parallel lines. And these only apply when our lines are parallel. So the beginning part for each of these is going to be if a transversal intersects two parallel lines. The transversal intersects two parallel lines. Then, dun, 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 dun. So this is going to be the starting point for each of these theorems. So go ahead and write it out for each one. If a transversal intersects two parallel lines. And while you write it out, I'm going to copy and paste. Haha. I thought I hit clone, but it went away. That's my favorite thing. I wish Control Z worked like all the time. Oh, I did hit whoops.
Oh, that's not fair.
Hey, I've written these lines way more often than you guys have, so I'll get a little fancy with it. Okay, so ideally, this helps ingrain in your brain.
Oh, it's different. I didn't know it was 3 seconds.
Hopefully this helps ingrain in your brain. These apply only when our lines are parallel with the transversal cutting through. Alright, so let's go ahead and take a look at that particular situation. Alright, so I've got a set of parallel lines. And remember the notation on our picture to indicate they're parallel is that they draw in a little arrow. This indicates these are parallel. If I have more than one set of lines, they'll do like 2 little arrows or 3 little arrows. Alright, and then let's go ahead and draw the third line. Alright, so what I have here are 2 parallel lines. I'm just going to call this A and B, and my transversal C. So again, this is the transversal. Okay, so it says, we're starting off with the corresponding angles postulate. The corresponding angles one is the only one that is the postulate. The rest are theorems. If you mix that up, I'm not going to be picky with that, but just keep in mind it's corresponding angles postulate. Alright, so I'm going to go and throw in some numbers again, just to help us out as we talk about these.
So let's say that there's 2 parallel lines or 2 corresponding lines there.
So it says if a transversal intersects 2 parallel lines, then, and so we're talking about corresponding angles first, so then corresponding angles let's take a look at our picture. So if the transversal intersects two parallel lines, then corresponding angles are... What do you guys think? First of all, let's go ahead and state a pair of corresponding angles. Who would like to offer what a pair of corresponding angles? Rachel. 1 and 6. Beautiful. So I have corresponding angles 1 and 6. What do you guys think these two angles are? Congruent. Good. Do we all agree it looks like it's congruent? It's basically, because these are parallel, I've taken this and copied and pasted. Well, I actually copied and pasted. But basically the idea is it's been copied and pasted, right? So we have that they are indeed congruent. And remember, a postulate, we agree is true, but it's the foundation, it's our beginning point, so we cannot prove that is true. Yes. We're good. All right. So now let's take a look at alternate interior angles. Who would like to give me one set of alternate interior angles? Sorry, let me change. What is one set of alternate interior angles here? 7 and 3. Good. Thoughts as to what 7 and 3 are going to be? They are congruent. And if you think about it, we could apply the congruent supplements theorem, which says two angles supplementary to the same angle are congruent. We would go through and say 7 and 1 are linear pairs, thus they're supplementary. 3 and 6 are linear pairs, thus they're supplementary. Since 1 and 6 are the same, we could substitute in, have 3 and 1 are supplementary, and then 2 angles supplementary to the same angle are congruent. Boom, we just proved the truth. Alright, but good. Alternate interior. Then alternate interior angles are congruent. I'm fine if you guys abbreviate alternate interior angles. You'll notice that these titles actually get kind of lengthy because there are so many pieces of it. Just make sure that when you refer to the theorem, you don't forget to say theorem. If you just say alternate interior angles, then that's not the theorem. The theorem is what tells us they're congruent. Okay. Next up, we have same side interior. So this one. Alright, so if the transversal intersects two parallel lines, then same side interior or consecutive interior angles are... Alright, let's take a look at this one. Who would like to offer up a pair of same side interior angles? Here. Good. Angle 8 and angle 3. What do you guys think 8 and 3 are? Supplementary. Good. So we do have that they're supplementary, and if we think about the proof for it, we know 3 and 2 are corresponding, right? 2 and 8 are linear pairs, so they're supplementary. And 3 and 2 are corresponding, then by that postulate we have they're congruent. I can just substitute that in and say 3 and 8 are supplementary. And alright. Then same side interior angles are supplementary. Okay. Questions so far before we take a look at alternate exterior? Okay. Alternate exterior angles. Who can describe for me a pair of alternate exterior? 2 and 5. Good. Oh, their shapes do have. Pentagon. Oh, hey, that's a pretty good pentagon. Oh, I messed up already. Okay.
Yeah.
2 and 5. They are alternate exterior. What do you guys think these ones are? Congruent as well. Good. And once again, we can go through a series of, let's see, 3 and 5. What do we know about 3 and 5? The vertical angles. The vertical angles theorem tells us these are congruent. And then, once again, corresponding angles postulate would tell me that 2 and 3 are congruent. Do some transitive property there. We have 2 and 5 are congruent. Alright, so if a transversal intersects two parallel lines, then alternate exterior exterior angles are congruent. Alright. So just to emphasize what we looked at here, corresponding angles, congruent. Same side, or sorry, alternate exterior, congruent, and alternate, that was alternate interior. Alternate interior, congruent, alternate exterior. These three sets are all congruent, again, only when the lines are parallel. Our same side interior is the oddball, and supplementary. Alright, so now we have to address same side exterior, since that's been added on. And again, we've always talked about this, we just never explicitly addressed it. So now let's take a look at same side exterior. Same side exterior. Alright, so we're going to kind of write this down informally. So you can give me a pair of same side exterior. Go ahead. 4 and 2, awesome. Okay, what do you guys think same side exterior are? Supplementary. And again, we can go through the process of when you're paired, that's their supplementary. Corresponding angles postulate tells us those are congruent. Substitute that in, we get 2 and 4 supplementary. Good. So same thing, same side exterior, got angles, theorem. So same idea. I'm going to write this in, again, very informally, but we've got parallel lines, same side exterior is supplementary. Okay, so basically it's the same idea, same side interior. It's true for same side exterior. You'll notice our emphasis is more so on these ones, but it is also true for same side exterior. Okay, questions on this? Nothing too crazy today. The key thing is that you remember this is only true for parallel lines. So these are theorems and postulates. I'm going to highlight that as well. Because I will ask you to use these to justify, and you need to state that's postulate theorem. Okay, so these theorems and postulates only apply when we have 2 parallel lines with transversality. So let's go ahead and take a look at that. Okay, so coming around to you are just some summary of what we just said and some examples with this. Is there anyone that did not get a copy of our notes and examples? Alright, so just as a reminder there, remember when 2 lines are parallel, again they have to be parallel and then cut by transversal. The corresponding is congruent, alternate exterior is congruent, alternate interior is congruent, and same side interior supplementary. Let's go ahead and add on the same side exterior for consecutive exterior. Same side exterior angles are supplementary. So we got 4 more theorems in our pocket. Theorems postulates. Again, I'm okay with use of even like core, angles, alt x, alt int. But I do need you to write out same side, not just s, same side interior, same side. Okay, so our first one here just says identify all the numbered angles that are congruent to the given angle and justify your answers. Let's go ahead and do number 1 together. So they gave us 132 degrees here, and it said to identify all that are congruent. So what else do we have as congruent to angle 132? 3, 5, and 7, I've heard. Do we agree? 3, 5, and 7, we're okay with that? Okay, so let's talk about each one individually. How do I know that angle 5 is congruent?
Oh, wait, never mind.
By corresponding, good. So by corresponding angles postulate. Again, notice you have to specify we're talking about the corresponding angles postulate. The definition only lets me identify. Notice the trend. A lot of times the definition is just let me identify things. There's some postulates that let us make conclusions about characteristics about things. All right. How do we know angles? I should have started off with the going in numerical order, but that's okay. Let's go 7. How do we know angle 7? Number 7, alternate exterior. Get by alternate exterior angles theorem. Okay, please abbreviate each one of those. Yes.
Did you say that it's
Did you say what?
that it's also
So you could say 132 and 5 by, so if you want to take the long route, 132 and 5 by corresponding angles, 5 and 7 by vertical angles theorem, and then transitive property, because you have to list all 3. So the easier way is just because it says identify all that are congruent to the given angle, just keep going back to that given angle there. But you're correct. We just have to list each of those 3 steps. Okay, how about 132 and is that 3? Good. I have vertical angles there. Maybe just for you guys in the same version. Okay. So I want you guys to go ahead and try. Our next one's 2, 3, and 4. And again, write down the relationship right there in the postulate that lets you connect back to the original angle. Okay. So like we did here, just keep going back to the original angle for each one. So try 2, 3, and 4. You're welcome to do this with shoulder partner or by yourself. You can come answer questions. Yes, Ron.
What does
What does what? Are you good? Okay. So they gave you 78 degrees. Yeah, so guys, they give you one of the angle measurements, and you're going to identify all congruent ones to the angle measurements there. Exterior. Look, it's 20 feet.
Yeah,
No, man.
so finding the anyone needs to erase your last class.
This is in here.
Well,
David,
and you this.
That's why.
Number one for
okay, so the 8 is an 8.
eight doesn't work. Well, for my son.
I did not.
It would be 7, 1, and 7. Yeah, 7, 1, and 5.
Seven by corresponding, 5 by corresponding.
Wait, corresponding angles of bottom.
Alright, let's go ahead and take a look at 2, 3, and 4.
And then angle. When Alright, you get 7, 1.
Alright, go ahead and check your answers for 2, 3, and 4.
Okay, I knew it. 5 is alternate interior angle. I swear, I told you it was not corresponding because I didn't say it out loud because I was scared that I got it wrong. So I got it right.
Okay, I do see a tiny little error on mine. It should say corresponding angles postulate. Again, if you actually put theorem, I won't take off, but it should be postulate.
We started pointing over there. I thought you were going to say 5 is wrong, and I got so nervous.
Again, make sure you have theorem or postulate at the end of each of these. If you are justifying that these angles are congruent or supplementary, it's your theorem or postulate that tells us that. Alright, so we have questions on 2, 3, 4, 4. I see some of us frantically read it, so I want to make sure we actually understand it, not just. We're good? Okay. So let's take a look at 5, 6, 7, and 8. So it says to actually find the measure of angle 1 and angle 2 and justify each answer. So let's go do 5 together. So we have angle 2. What would that be? What would be the measure of angle 2? Good. And make sure you write the notation correctly. Measure of angle 2 equals 130 degrees. What would be our reasoning for this? How do we know it? Corresponding angles postulate. Good. Like corresponding angles postulate. Now, okay, first actually let's do the next one and then I'll talk about something important. Okay, what's the measure of angle 1? 50, and how do we know that guy? They're supplementary, how do we know they're supplementary? Linear pair postulate. Linear pair postulate. Now, I want to talk about in the world of justifying now. So in Unit 1, I made you first identify that something was a linear pair before applying linear pair postulate. I made you identify that something was vertical angles before applying vertical angles theorem. Technically, we should identify first that these are corresponding angles by definition of corresponding angles, and then say that they're congruent by corresponding angles postulate. But I trust that we have graduated from Unit 1 to Unit 2 with the understanding that you can look at this picture and recognize these are corresponding and just go ahead and apply corresponding angles postulate. I trust now that we can look at the picture, recognize these are linear pair, and just go ahead and apply linear pair postulate. And I trust that we can recognize, do we have vertical angles anywhere? That, here, I trust you can look at the picture, recognize those are vertical angles, and just apply vertical angles there. So from here on, I'm not requiring you to do definition of linear pair to identify, definition of vertical angles to identify, or definition of all of our corresponding alternate interior, alternate exterior, same side interior, same side exterior before applying the postulates. I trust you can look at the picture, identify them in your head, and go ahead and apply their postulate. With that being said, you do still have to first apply linear pair postulate before you can say the measures that to be 180 by definition supplementary. That's totally sounds good. But you're no longer required to identify those different types of angles by the definition before applying those postulates. Are we okay with this? I only got 3 heads shaking yes. Are we all okay with this? Okay. You are always welcome. Aiden, you can go ahead and write out the definition. But you'll notice that I will remove that from my pictures. Also, with same addition postulate and angle addition postulate, those are defined as measures add up to be the big one. And then we would have to use definition congruent statements to switch it to congruency. I trust that we now can also accept that angle 1 plus angle 2 is congruent to angle ABC. We're not doing that right now, but you'll see that in the future. Okay, so for 6, 7, 8, I want you to go ahead and continue the same idea. What are those measures? I made up a few. What are those measures and how do you know justify it? If you happen to finish 6, 7, 8 before we get to it to go over it, just go and continue working. This is part of your homework finishing this up, so anything you finish now, you don't have to finish here. But go through 6, 7, 8. State what we know that angle measure be and justify. And notice it has to be a set of parallel lines, right? They gave us parallel notation here and here. They gave us parallel notation here and here. Be careful here with number 8. I know that these lines are parallel, but not these 2 lines. S and T are not parallel. Okay, so again, work with your shoulder partner, those around you, raise your hand, ask questions, come up and see me, I can answer questions. Yeah, so it's, you might just want to say like angle 1, since you have angle 1. Hold on, Mitchell and go back.
So, but I don't know how to.
I alternate exterior. Exterior Wait, so 7 is 7 is alternate.
What was the whole
Talking about 7.
Angle 1 would be
Wait, how does that? Oh, wait.
alternate.
No, it's inside the line. 2 lines that go like this, and it's on the opposite side.
Yeah, so
What I'm saying? It's 2 parallel lines. They're on opposite sides of the
anything outside of so this and this are vertical.
Alright, then what's 2? Oh, what is
Certain sides are congruent.
well,
So yeah, but
It'll be 61 degrees.
so it's same side.
No, it's not.
also
Number 2 would be it would be consecutive. Elijah, he's consecutive.
Wouldn't one be corresponding? No, they're different. Yeah, those are 1 and 82. So that's
So you agree with him on that when I said it's like I'm seeing how they're good. So
But I write that.
alright, now you don't need to rush in.
okay. So think about it. It's outside the line. It's on the outer side, but the other one's on the inside. So even one way inside, you have to compare two digits both on the inside. One on the inside, and they're not corresponding. They're on opposite sides. So linear pairs. Which one? The exterior.
I guess you could say.
Wait, one is equal
Number
to
two.
A, right? Isn't it 58? What? How?
These are supplementing 58 number doors. The whole girls. They don't have to they can use 58 if you have they're hell. So 180 minus 122. Yeah.
What are we trying to find?
Linear pair.
Nope. So then you can have your numbers. So
Don't look at the other. Don't look at the
I don't know, you told me that
You saying 5 and 2.
I don't know.
Oh, no.
I know that it has to be these or something, but I know what
How do you know those are supplementary? What type of thing?
Like ask me
But like which specialty? What others? 15 and 2? Linear pair has to be right next to each other, right? This angle next to that. 2 and then say good. So we've got, it is actually the circle, but let's take your corresponding. Right? Good, so I wish I had the name for that angle. Just pretend it goes in. So we could say superior corresponding, or what's almost shows the same, and then we've got those.
so everything will be
So it'd be like, so the corresponding corresponding.
Alright guys, let's go ahead and take a look at our next three. Corresponding angle. Yep, linear pair. Okay, let's go ahead and take a look at these ones real quick. Now for 6, 7, and 8. For 6, 7, and 8, some of these required actually a couple of theorems, or I guess it was only number 8. So number 8, you actually have a few different ways you can do this. 2 and 58 degrees don't have any special angle relationship, but you could say first corresponding and like take 2 down here. And then these would be linear pairs. So corresponding angles postulate and linear pair postulate. You could have instead said vertical angles theorem. These would be congruent, and then same side interior angles theorem. So you actually had a couple options there, but you had to apply 2 different theorems of postulates to get that connection. All right, so we have questions with 5, 6, 7, or 8. Okay. So your homework is to finish this classwork, and at the top of it, I want you to write down finish this and our textbook numbers, which are page 152, numbers 1 through 20, 25. That's out of the textbook. So finish this page and do these textbook numbers. No, don't finish theorems and postulates. We'll be doing that during class. Okay. Real quick before you guys go, I've had a few people talk to me